Hi, let's discuss data types in Rust. First of all, I'd like to define what exactly data types are. So suppose you declare a variable and you want to assign some restrictions to that specific variable. That particular variable could contain data of a specific genre or a specific type. So suppose you want a variable to just hold names or just hold addresses actually, and if you want to one particular variable to have only numbers, then you can do this particular constraints, or you can make these kind of constraints using data types. Now just for an example, I could show you, like if I initialize integer like let a is equal to 7, it means a can have values which are in numbers. Similarly, if I say name is John Doe, then name can have values which are related to names or strings actually. So these are basic data types. Now if you have some programming background, you might be quite aware of these. So I'll tell you what exactly are the types of data types actually in Rust, and there are basically two different types of data types on a higher level. The first one is scalar type and the second one is compound type. Now if we talk about scalar types are basically those variables which have single values. Whereas if you go for compound types are variables which have more than one values in them. Examples of scalar type are integers or floating point types or Boolean or characters. Whereas for compound types, it is tuple, it is array. We are not discussing string here because in order to understand string, we'll have to go through the concept of ownership. And in the coming lectures, I'll be covering ownership. So before discussing string in Rust, I'll prefer going around with the concept of ownership. Let's start with integer data types. Now, integers can be broadly classified into two different types. The first is signed and the other one is unsigned. Now, what is the difference between signed and unsigned? Now, signed integers are basically those integers which can contain both positive and negative integers, like those variables which can contain both positive as well as negative numbers, which include 0 as well. Whereas unsigned are basically those variables which can only contain positive integers, which include 0 as well. Now if you want to specify a data type for a specific integer and you want to make it signed, you'll have to add a prefix when you are declaring the data type of that specific variable with I. And if you want to declare a variable which is unsigned integer, you have to start the data type with U. Now there are various sizes of these, there are various ranges, I would say, of these variables actually. So if I make a particular variable with data type I8, it means it can contain numbers from -128 to 127, and this keeps on increasing once you multiply it with 2, like I16, I32, I64, I128. Similar goes with unsigned integers. U8 will contain from 0 to 256 because unsigned variables can only contain, unsigned integers could only contain positive values including 0. So you'll have U8, U16 has a better range, U32 has a bigger range. Now if I declare a variable and I do not assign a specific integer data type to it, but I still assign it an integer value, by default it will become I32. Like it will be a signed variable with 32 range. Actually the range will be this one. Just to give you an example, what I'll do is I'll initialize a7, I'll print it, or let's make it -7. What I'll do is I'll print value of a, and I'll mention a here, put a semicolon, do a cargo. First let me clear this. Cargo build is finished. Cargo run. The value of a is -7. What I'll do is I'll try to assign it, or basically make it an unsigned variable. As you remember, unsigned variables are, or unsigned integers are only those integers which can have positive values, right? But what if I assign it to this one? I'll do a cargo run or cargo build in order to compile it. So cargo build. Yes. Now you see, cannot apply urinary operator minus actually, because unsigned integers or unsigned data type can only contain positive values. And if you don't assign a specific data type to this, then a will automatically become signed integer actually. Now let's go ahead with floating points. These are quite simple. So if you declare a variable let x equal to 2.0, basically all those variables which have decimal amount or decimal amount of numbers in them are basically floating point types. Similarly, if I go ahead and declare a particular just like integers, if I go ahead and declare a particular variable with a decimal value, by default it will contain f64. And if I want to specify or narrow down to this particular data type f32, which has a smaller range, then I have to specify this. By default it will be f64. The third is Boolean. As you know, Boolean can contain only two values, which is true and false, but there is a catch here. If I say name a variable flag, let's say, and I assign it a value false, then it will automatically have a Boolean data type by itself. But what if I could show you the printed version as well. Print ln value, the value of flag. Cargo build, it goes ahead, cargo run. The value is printed, right? Now I want to show you that particular variable or a particular Boolean variable does not have a default value here. So if I say flag bool and do not initialize with any value, ideally in other languages like in Java or in Kotlin, if you initialize a Boolean variable, it will by default have a false value, but that's not the case with Rust. Rust will make you specify or initialize that specific variable, and it does not assume that there is a particular default value of bool variables actually. So if I compile it again, cargo build, it says we have not initialized that specific variable. So that's a catch. So there is no default value in case of Boolean types. Our fourth data type is characters. Characters are basically Unicodes or scalar values. These are 4 bytes only, which means 32 bits. And if you want to define a particular character, what you could do is I'll say flag itself is a character, or flag itself is a variable of character, and I'll assign it a value a. Okay, now if I consume this or say cargo build, it will basically compile and do a cargo run. It's visible, right? But these particular characters are only defined in single quotes. If I do assign a data type to this, in that case it will say that this is a different data type itself. It's not a character. So characters are only defined with single quotes, and there could be only one value inside, one alphabet inside it. That's the basic. Let's start discussing about the compound types. So the first compound type data type is a tuple. Now what exactly is a tuple? A tuple is a list of heterogeneous data types, or a list of heterogeneous elements actually. By heterogeneous I mean the elements inside the tuple could be of different data types. I could store a signed integer, I could store a float as well, I could store an unsigned integer as well in the same list. And if I want to make the list bigger, it is not possible. It is a fixed size by the time of initialization. So here, if I have set it up as 3 elements in the tuple variable itself, or the tup variable here, it will always contain 3 elements only. Now let me show you an example how to access these values actually. So I'll just copy the declaration here and say suppose you have like 3 elements in the tuple and you want to print those values. What you could do here is the values of tuple at index 1 is, you just have to write tup.1 and it will basically show you what exactly are the values. I'll compile it and I'll run it. So the values of tuple at index 1 is 6.4. Now, just like other languages, like index 0, this is index 1 and this is index 2. Now there is a small concept which I wanted to share with you guys. It's more like, we haven't covered the control flow statements, but if you have some programming language background, you know what exactly this means. This means if a particular statement is true, then you print this, else you print this. Now, since we have already assigned true here, we'll always print did something, right? Now, but you could see there is no return type in this particular function. We are not returning anything, right? So this particular variable will not have any values. It will not have any particular defined variable or a particular defined data type actually. Now what happens if we do not define a specific data type, or we do not return anything here? It basically gets the value of an empty tuple. Got it? I will explore more about this in upcoming lectures. Actually, I'll give you more examples on this part, but just try to remember this one. Now the second compound data type which I want to discuss with you is array. So unlike tuple, which is a heterogeneous list, arrays are basically homogeneous lists. Like it could contain elements of the only same, like it could contain elements of the same data type only, and it should not be different. So if I am making a list of signed or unsigned integers, it should always be unsigned integers or signed integers. If I'm making a list of strings, it should always be string. If I'm making a list of signed integer 32 variables or elements, it should always be of the same data type. Now the indexing here as well starts with 0, and if index out of bound occurs, it causes panic. Now what exactly is index out of bound? Index out of bound is like, say suppose you have a list of 4 elements, okay, or 5 elements as in example here, and you try to access the 6th element which is not there in the list. It doesn't work, right? The Rust code will, the Rust compiler will not be able to execute that. It will not be able to find anything, right? That's why it is called index out of bound. There is an example here as well. So usize and isize I'll cover in the next lectures. It is still not easy to define what exactly is usize and isize, so I need a different lecture for that. In order to just show you a brief example, I'll just copy this, replace it here, and I'll show you how exactly we should access the array elements. What I could do here is I could just write array, or A is the array name, right? So at index 1 is, I'll just, in the big brackets, I'll just push the index and I'll build it and I'll run. You could see the value of array at index 1 is 2, which is 2 here, right? If I try to access the element at 7 and try to build it, it will say index out of bound, because it is not possible itself. The compiler is so strong in Rust that it will automatically identify that this value does not exist in this, or these many elements does not exist in this list or in this array. Hence there is index out of bound which could be happening here. That's why without compiling, or at the time of compiling itself, without running, it shows us this particular error. Now there are two key concepts which I want to cover in Rust. I'll add it into the next video because this video is already very long, and hope to see you in the next one. Probably I'll create my next video on this one, and the next one will be on isize and usize actually. So see you in the next one.